Welcome in, everybody. In this video you will learn all about lines. And in order to do that, I will first go over linear characteristics, or the characteristics of lines, the different types of slopes, and how those affect the graphs of lines. We'll get into graphing lines. And then we'll get into writing the equations of lines, and at the end we'll talk about some special lines that exist out there in the math world. Let's get into it. Linear characteristics. We will look at many linear scenarios, but they will always boil down to one of the following. We will either need to have 2 points or 2 ordered pairs, which are the numeric representations of points, or we will be given 1 point and a slope. And we can get even a little more specific with this. A lot of the times we want that 1 point to be what is known as the y-intercept. And the reason we want to know this point is that it makes writing some equations of lines a little bit later a lot easier. Let's take a deeper look into slopes. A line's slope measures how steep it is, and there are 4 different classes of slopes. The first one is being positive. That is any line that moves up from left to right, and it can be flat, it can be steeper, but if a line is moving upward from left to right, then it has a positive slope. The next one is a negative slope, and if moving up was positive, hopefully you understand and it makes sense that moving down was negative. Again, it can be steeper or it can be flatter, just as long as it's going down left to right. The third class of slope is a zero slope line, which is horizontal, it's flat left to right. And then the last class of slope is undefined, and a line that has an undefined slope is vertical. Now we can include the axes here. So the x-axis is actually a zero slope line, and the y-axis is actually an undefined sloped line. And these 2 slopes are going to come back toward the end of the video when I start talking about special lines again. One other thing I want to point out here is that we have some other words to represent this. These lines we would say are increasing, aka moving up from left to right. These lines are decreasing with negative slopes, aka moving down from left to right. And these lines are what we call constant. They're flat from left to right. Graphing lines. So now on this slide, I want to get into doing some actual graphing. And given what I said in a previous slide, all linear scenarios, all line scenarios break down into one of 2 forms. Either you have 2 points or a point and a slope. In this case, we have 2 points. So if you want to graph the line passing through these 2 points, all you have to do is graph those 2 points. So here they are. This is 3, 6, and this is -4, -8. And in order to graph, all we have to do then is connect these 2 points and extend a little bit past those 2 points, like this. And once you do that, make sure you put some arrows at the end of your line, because this does go on forever. That's it. That's how you graph a line if you have 2 points. Plot the points and connect them. Pretty straightforward. From there, you want to find the slope of that line. So how we're going to do that is use this idea of rise over run. Basically, we're going to take the slant of this line and put an actual measure to it. So what does it mean to rise over run? Well, we can do this one of a couple different ways, but it involves with picking a point. So you would want to pick a point to start with. And just for simplicity purpose, I'm going to start with this point here. And since rise is on top, I'm going to do the rise first. And what that means is I'm going to go straight up from that point until I get to the same level as the other point, the same level as the other point. So once we get there, how far did we rise? All we have to do is count. So again, we're jumping by 2's for each line here. So 2, 4, 6, 8, 10, 12, 14. Go ahead and mark that down. And I will mark it down here as well, 14. All right, next we have to figure out how far we are running. And what that means is how far do we have to move horizontally. Rise makes sense for vertical, run makes sense for horizontal. All right, so that means all we have to do is come over here and from that point where we stopped, run to the next run to the next point. Turns out that is a run of 7. And once we get this, we can simplify this fraction to be 2. So the slope of this line is 2. Okay, that is not the only way I could have traveled using only vertical and horizontal movements to get from this line and this line. I could have done a little stair step here and added up all of the vertical movements and all of the horizontal movements. That's a little bit of a pain, so we'd like to make all of our vertical movements and horizontal movements at once. But again, we could have run first if you want. You could run this way. It's still a run of 7, and then you could have risen up 14 to get there. That still doesn't change the order of the fraction over here. The run was still, or the rise was still 14, it still goes in the numerator. The run was still 7, it still goes in the denominator. And our slope still would have been 2. But let's say you're just the rebelist rebel out there and you want to start at this point and go to this point. What's going to happen? Well, it turns out you're just going to be getting a slope of 2 again. So let's say you start at this point. I'm going to change colors. You start at this point and you go backward 7. If you go backward, if you move to the left, that ends up being a negative movement. So your run this time would be -7, and I'm putting that in the denominator because that's where horizontal movements go. From there, we would have to move down 14 to get from this point where we stopped to this point on the line. And just like the opposite of right is left, the opposite of up is down. And if we move down, that is a negative movement. So it'll be a -14 over a -7, which, wouldn't you know it, still reduces to 2. More graphing lines. On this scenario, we have a point, and now we're given a slope. So with a little bit of knowledge gained already in this video, we're going to move with this slope, and we're going to learn how to graph using a slope. So when the slope is -1 over 2, like this, you want to just move that negative into the numerator. And what that will tell you then is your rise and your run. Cool. So what this is telling me then is from this point right here, graphed already, point C, we want to rise -1, and that means we're going to move down 1. And then we're going to run 2. So down 1, run 2. That point right there. Down 1, run 2. That point right there. And we're just going to keep repeating this process. Down 1, run 2, down 1, run 2, down 1, run 2, down 1, run 2, so on and so on. Oops. And so on. You think we've got enough dots here for a pattern? I think so. So once you start applying the slope, then you want to draw in your line. And there you have it. We have drawn in the line using a point and a slope. Now, unfortunately, you are not always given a point and a slope and a graph to just start graphing lines. Sometimes what ends up happening is you're given the equation of a line and you'll have to graph it from there. And one of the big points that we will need to work with or remember is that we need a point and we need a slope. So we understand how the slope works. We were given a specific point. I want to take a time right now really quickly to identify two other really important points, and it's this one right here as the x-intercept and this point right here, which is the y-intercept. And these points are very important, or maybe nice, because they're generally pretty easy to find given an equation. What is an x-intercept? What is a y-intercept, you might be asking? An x-intercept is the ordered pair, the point where a graph, and this is for future reference, any graph crosses the x-axis, and a y-intercept is where the graph crosses the y-axis. So this point right here, the graph crosses the y-axis, and this point right here is where the graph crosses the x-axis. And we can even give these points some ordered pairs. So this one is actually -3, 0. And this ordered pair is 0, -3. So one important takeaway with the intercepts is where they cross, is where a graph crosses that particular axis, and every single x-intercept will have a 0 y-coordinate, and every single y-intercept will have an x-coordinate. The last example for graphing lines here will be from an equation. And in its current form, we do not have a very easy way to know what the slope and y-intercept are. But we can find the slope and y-intercept by following two steps. We can solve this equation for y and then do any simplification that we might need. So in order to solve this for y, I need to make sure I get all terms with y on one side of the equation and all terms without y on the other side. So you can see the only term with y right now is this one right here. It's on the left side of the equation, so I want to get all other terms without y on the right side of the equation. And we can do that by doing the opposite operation here. So I will add 3 x's to both sides. I'm going to do this right in front of the constant term because math conventions say that that's the nicest way an equation can look. 3x minus 2. One other thing is, you notice I'm only operating on the term 3x. That does not include the sign behind it that stays with the y. But we need to take care of it, and since it's a -1 being multiplied to a y, we can divide each term by -1 to get the equation y equals -3x plus 2. Now I bet you're wondering, how is this gonna help? Well, this equation is in what we call the slope-intercept form. And what that does is it gives us information about the slope, which is the number being multiplied to x, and the intercept, most specifically the y-intercept, and that is just the constant term being added out back. So let me write that equation off to the side here. Y equals mx plus b, where m is the slope and b is the y-intercept, including the sign of the term. So there we go. So as you can see, the number that is being multiplied to x here is -3, so we know that's the slope, and the y-intercept is 2 because that's just the constant being added or subtracted out back. Now, how are you supposed to use this to graph on the coordinate plane? Well, the letters here tell you everything, B and M. So we're going to begin by plotting the y-intercept, which basically means all you have to do is find that value on the y-axis. So right here. Then we're going to move from that point using the slope. And you're taking a look at this slope and you're like, that's a 3. I need a rise and a run. Well, just remember this. You can always turn any whole number into a fraction by putting it over 1. So there's a rise in the top and a run in the bottom. So since the -3 is in the top and that is a rise, that's going to tell us to move vertically. But since it's negative, we're going to go down 3. And we're going to run 1 to the right because it's a positive 1. And we're just going to keep repeating that process over and over and over. I think that's enough there. And I didn't go over this in the last example, but we do need to go to the left as well. So we started at the y-intercept and only went to the right. But we need to go left as well. So how would we go to the left? We would take the opposite of all the directions we were moving. So instead of down 1 or down 3 and right 1, we would move up 3 and left 1. So right there. Up 3, left 1, right there. Right there. Okay. So now all we have to do is draw our line in, put some arrows at the end of it, and we have a line graphed. From finding graphs of lines given some information, we're going to go to finding the equation of the line given some information. Fortunately, I will be using a graph to bridge the gap between these two ideas. So you can see what's being asked here. Find the equation of the graphed line, this line right here. Based on the last example, we can find the equation if we can find the y-intercept, aka where this graph crosses the y-axis, like right there, and we can find the slope of this line. So let's see what we can do here. We can see that we have a y-intercept of 0, -2. So we'll note that, 0, -2. And now to find the slope, since we only have 1 point right now, we need to have 2 points to find the slope. We can then pick any other point that's on this line that has some nice coordinates. Right, maybe that one, or probably even that one. So any other point, in fact, any of these 2 points will work. So let's go ahead and stick with the first 2 that I picked. The y-intercept will be one of them, and you can pick any of these other points you so desire. I'm going to pick this one, and I'm just going to use my rise over run technique to find the slope between these 2 points. So first, I'm going to rise, let's see, from here to here, and then I'm going to run from here to here, and I just have to count. How far am I rising? How far am I running? Well, it turns out I'm rising 4, and I'm also running 4. So what that means is the slope will be 4 over 4, and yes, you want to simplify fractions if you can. It simplifies to 1. Now that we have the slope and the intercept, we can use the slope-intercept form of the linear equation. Again, m being slope and b being the y-coordinate of the y-intercept. So all we have to do then is make a couple substitutions. I'm going to take this 1, substitute it in for m. I'm going to take this -2 and substitute it in for b. leaving us with the equation y equals x minus 2. You don't have to write the 1 if it is the number in front of a variable, and adding a negative 2 means you're just subtracting 2. So this is the equation of the above line. What if we started looking at finding equations, but you didn't have a picture? You would imagine it would get a little harder, right? The slope formula. The slope formula is needed if you aren't given a graph to work with, or maybe you just don't have graph paper, like most people in their everyday life. So if you know 2 points, you can find the slope. As I mentioned in the last example, you have to have 2 points to find the slope of a line. And if you can find the coordinates of those points, then you can use this formula, m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, or you can use this fraction here. This is how it's taught most of the time. So one thing I want to point out, it doesn't matter which you use as long as you keep the ordered pair above and below each other. You don't want to be trying to put the y coordinate of one point above or below the x coordinate of a different point. Y sub 2 and x sub 2 are above and below each other here and here. That being said, all we have to do is identify the coordinates and we can find the slope. So let's do that with this example down here. Oh, and oh look, this still fits the scenario. We have 2 points, right? Most linear equations are going to come down to 2 points or a point and a slope. Hint, nudge, wink. That's what we're moving to. So find the slope between these 2 points. All you have to do is set up this equation like this. I identified where x sub 1 and y sub 1 were. I identified where x sub 2 and y sub 2 were, and then I just substituted those values in here accordingly. From here, all you have to do is simplify the top. Negative 8 minus 6 is negative 14, and the bottom, negative 4 minus 3 is negative 7, and simplify that fraction to 2. And what happened here was I just used the slope formula to prove, without a picture, that the very first graphing example you looked at, the slope of the line in that graph is 2. These were the same points given in the very first example. So you don't need a graph to find the slope of a line. You can use the slope formula. Why would this be helpful? So in finding equations, you will need one of those 2 scenarios I keep talking about, either 2 points or a point and a slope. So for example, find the equation to a line passing through 3, 2 with a slope of negative 5 over 3. So we've already talked about the slope-intercept form of a line, but only in terms of when a graph is available and we can find the intercept. It turns out this is not the y-intercept for a line passing through this point, so we don't know the y-intercept in this case. If you know the y-intercept, you can just plug the y value right in for b, you can plug the slope right in for m, and be done with it. In this case, we know that we have an x sub 1 and a y sub 1, and we have over here a slope. So with this, what we can do is we can substitute the slope in for m, so negative 5 over 3. We can substitute the 3 value in for x, so I'm going to say 3, and we can substitute 2 in for y. And what that does is it leaves us with an equation that with only the b variable left. So what we can do is we can solve this equation for b. So in order to do that, it looks like we can reduce the 3's here, right? 5/3 times 3, this is a 3 being divided by another 3. We're just going to be left with a negative 5 there. Plus b equals 2. And if we add 5 to both sides, then we get b equals 7. And that's not the end of this example. Yes, we found the y-intercept. Take a moment, feel the sense of accomplishment, but we're asking to find the equation to a line. And that looks like this, with a slope and a b value or a y-intercept value substituted in there. So our final answer is going to be y equals negative 5/3 x plus 7, that b value we just found. So I've mentioned a few times, this is what is known as the slope-intercept form of a line. But there's another form of a line that is very helpful for this particular scenario when you're given a point and a slope. And that is called the point-slope form of a line. And here is what that equation looks like. This is a point-slope form of a line because this allows for a slope and any point to be used in this line, not just specifically the point of the y-intercept. So what we can do over here is we can still find the equation of a line, but literally just by substituting numbers in. So I'm going to have a y minus, what is that, 2, right? That's the y sub 1 value in our ordered pair, equals negative 5/3 times x minus, and the x sub 1 value we have is 3. Okay, now I know what you're saying. These lines don't look anything like one another. Well, again, if we just follow that process for when we were graphing lines, solving for y and simplifying the right side of the equation, you will see very quickly that this equation simplifies into this equation. So I'm going to just take some time and release some steps slowly so you can see how that works. And there it is. So in this particular scenario, I've sort of flipped the steps that I gave a couple slides ago, right? It was simplify and then solve for y. That's what I've done here. The previous steps were solve for y and simplify. But we ended up at the same result. It looked easier to simplify this first. So what happened, I distributed negative 5/3 times x, which is just negative 5/3 x, and negative 5/3 times 3, which is what we did over here. The 3's cancel, we were just left with negative 5, but negative times negative is a positive, so that's how that worked. Add 2 to both sides to isolate the y, 5 plus 2 is 7. Yeah, we got the same equation. And the reason I like the point-slope form of a line a lot more is because really it just allows you to substitute in some numbers, and we could have stopped here. The only reason I went and simplified it to slope-intercept form is because this is easier to graph than this if you're just given an equation, and just to show you that this equation was equivalent to this one. For the last example on finding equations, we're gonna just simply find the equation of a line passing through these two ordered pairs. And this is different from the last example because in the last example I went over both of these equations, y equals mx plus b, and y minus y sub 1 equals m times x minus x sub 1. And what these equations have that is missing from being given to us are the slopes. So the first thing you have to do when you are given two ordered pairs and you're asked to find the equation of a line is to find the slope. From there, you can use either equation of a line that you like and be happy with it. So let's first find the slope for this line. To find the slope, I'm just going to go back and use the slope formula, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And then just simplify across the top and bottom. Negative 11 minus 9 is negative 20. 0 minus a negative 5 turns into addition, all over 5. The slope is negative 4. Now that we have the slope, we can use either the slope-intercept equation or the point-slope equation. And I think I'm going to use the point-slope equation first because that's a whole lot easier to work with, in my opinion. So I will have y minus equals, well, the slope was negative 4 times x minus. The problem I run into is I have two ordered pairs to pick from. And you might say, hey, I see y1 and x1, so I'm going to use these numbers here. That's fine, use those numbers. But I want to point out that you can use these numbers as well. I'm going to stick with these numbers for now. So we will substitute 9 in here and negative 5 in here. And in the last example, I just kind of left it at this. I said, this is the point slope form of a linear equation. And it wasn't quite right because are some simplifications we want to have happen here like this. You don't want to leave it as subtracting a negative, so make sure you change it to addition, like this. All right, let's work with the slope-intercept form of the equation. So let's see. We can choose, again, now that we know the slope, we have to use the slope in x and a y to put a b in here. So we can use this ordered pair again, that's fine. So let's see, I will have 9 equals, the slope is negative 4, times the x value is negative 5, plus b. So again, the y value I took from this ordered pair, the m we found here at negative 4, and the x value I'm taking from that same ordered pair where I got the y, so negative 5. You can solve for b on your own and find out that b equals negative 11. So from here, this is not the answer, this is just the y-intercept value. So now we have the equation y equals negative 4x minus 11. So there is the slope-intercept form of this equation, or of this line that passes through these 2 points. Now, we did not have to go through this entire process to find b. We could have just distributed the negative 4 here and added 9 to both sides to get the same equation. A slightly more clever way to figure out the slope-intercept form of the equation is to recognize that negative 11 in this equation is the y value of the y-intercept. And a y-intercept will always have a 0 x value. So this might happen only once in a while, but the y-intercept was actually given here. So once we knew the y-intercept, if you noticed that was the y-intercept to begin with, we could have just taken negative 4 and substituted it in for the slope, and then took negative 11, which is the y value of the y-intercept, and substituted that in for b. All right, thanks for sticking with me. I promise this is the last slide here. We have special lines, and I put special in quotes because they're still lines. It just so happens that these lines are either going to be vertical or horizontal. And vertical lines end up having the equation x equaling some number, and horizontal lines end up having the equation y equals some number. And you might have to solve for x or y in one of these cases, but just know it's really not, these lines go very quickly. So how do you graph these lines? Well, I'm going to make a point about which variables show up in the equation to hopefully help you understand what's going on. So as I mentioned long ago in this video now, Lines will have an x and a y-intercept. And part of the reason of why that happens is because the equations both have an x and a y. Now, what does that mean for the equations you see in front of you down here? This equation only has an x. So this linear equation, when we graph it, should only have an x-intercept. And really, that's where we're going to start with graphing this. We have to find this number on this axis. So we have to find 4 on the x-axis. It looks like that is right over here. Let me grab the pen. There we go. Now, this line needs to cross the x-axis only. So it can't be slanted in any way that it'll cross the y-axis. So the only way that if we can draw a line through this point so that it will never touch the y-axis is to make sure it's slanted the same way as the y-axis. So it has to be a vertical line just like the y-axis. And we can talk about different intercepts and slopes here. The slope, we would say, is undefined. We can say there is no y-intercept, but there is an x-intercept here, right? There is an x in the equation after all. So x-intercept at 0, oops, I'm doing that backward, 4, 0, there we go. And we can do something similar for this other equation. You see it's negative 3y times 15, but we can't graph that yet because we need to solve for y. Solving for y involves just dividing by negative 3 on both sides, so we'll get y equals negative 5. Now that we have y equaling a number, we know it's going to be a horizontal line. So we're going to follow a very similar process. We're going to find this number on this axis. So find negative 5 on the y-axis, and it looks like that will be right here. And this line should only cross the y-axis because it only has a y in it, right? It can't slant up at all because eventually it'll hit the x-axis. It can't slant down at all or negatively because eventually it'll hit the x-axis, which means it has to have the same slope as the x-axis. And this is what the graph of a special line would look like. And then again, we can go backward from this as well. If you're given the line, then you can find the equation just by finding out what axis is that line crossing. It's crossing the x-axis, boom. Where is it crossing that x-axis? At 4. This line is crossing only the y-axis. There it is. Where is it crossing the y-axis? Negative 5. I hope this video helps you out. Thanks for watching.